The diagram shows a right angle trapezium ABCD with AB parallel to CD, AB perpendicular to BC, angle AMB equals 75 degrees and angle DMC equals 45 degrees. Point M is on BC and MA equals MD. Prove that AB equals BC. So for this question, what we really need to prove is AB, that's this side, equals BC. Now to do that, I think, and the way I have done the proof is by trying to prove that ABCD, first trying to prove that if we have to draw a line that's parallel to BC and somehow managing to draw a rectangle first and proving that it's a rectangle, and then going on to prove that the shape or the quadrilateral is a square. So other than that, there's no way AB would be equal to BC. It has to be a quadrilateral and it has to be a square. That's only when AB equals BC. If it is a rectangle, then AB is not equals BC. So that is our plan of going about with the proof, and it's a long proof. It will take a bit of time, so we need a bit of patience, right? So that's, as a start, what I did was I put down the facts that have been given in the question. So the question first says AB is parallel to CD, so I put the notations showing AB is parallel to CD, and then AB is perpendicular to BC, so that's AB perpendicular to BC, meaning angle ABC is 90 degrees. Then angle AMB is 75 degrees, angle DMC is 45 degrees, and then point M is on BC. It means BMC is a straight line, or angle BMC is 180 degrees. That's really what it means. And we have been given MA equals MD. So this is what we have to work with. So for a start, our proof by doing some constructions. So we add some extra lines, and we will be using them in our proof. So the first thing we do is we extend the line BC in both directions, so it becomes PQ, like B has been extended to the point P and C has been extended to the point Q, and so PBMCQ is a line, right? So the next one we do is we draw a line from the point A, which is parallel to PQ. Next, extend the line CD to meet the line XAY at E. So this is the line XAY, and we are extending it to meet that line at the point E, right? So from our constructions now, what we have is AE is parallel to BC, and we have AB is parallel to CE, that we have already given, but for the extra thing we've added is AE is parallel to BC, right? And the angles remain as they are. So the next thing we start with is in triangle AMD. So triangle AMD is this triangle. So we start with looking at this triangle first. In triangle AMD, so angle AMD would equal 180 minus 70 plus 45. So you add this 75 and 45, and you take off the sum from 180 to find out what this angle would be, angle AMD. And angle AMD, you will see, will be 60 degrees. Now we have been given AM equals MD, so the triangle is isosceles as of now. And so if one angle is 60 degrees, then the other two angles would also work out to be 60 degrees. So what I did was, they work out to be 60 degrees because the other two angles would be 180 minus 60 divided by 2, that is 120 divided by 2, and that is 60 degrees, right? So what you have given the reasons, yes. So and then triangle AMD is equilateral, AM equals MD equals AD, they're all 60 degrees. So the first thing we've proven is triangle AMD is equilateral. The next thing is in triangle ABM, so we work out ABM, this is our triangle ABM, we work out BAM, angle BAM or angle MAB, whichever you say it, that would be 180 minus 90 plus 75, and that gives you 15 degrees. So that tiny little angle, this is 15 degrees, right? The next we do is, now we know that XY is parallel to PQ by construction, and AB is a transversal, so AB cuts both the parallel lines XY and PQ, and so angle ABM equals angle XAB equals 90 degree. They're alternate angles, okay? And therefore what we can say is angle BAE is also 90 degrees, because if XAB is 90 degree, so here I missed something, that they are alternate angles. Okay, so then if angle XAB is 90 degrees, then angle BAE would also be 90 degrees, that is this whole angle would be 90 degrees because XAE is a straight line. So then we get angle, therefore, so we get BAE is 90 degrees and EAD, that is this tiny bit of angle, we can work that out now because we know the whole angle is 90 degrees, so 90 minus 60 plus 15 will give us what this angle is, and we see that is also 15 degrees. Okay, so then we move on to find out more angles. Okay, so AB is parallel to EC. Once more we're there, AB, so now looking at AB parallel to EC. AE is the transversal, because cutting it, AE is the transversal, yeah, and angle XAB equals angle AEC equals 90 degrees. So this is this one. XAB is AEC, so we are talking of this angle. So this angle and this particular angle, they are 90 degrees because they're corresponding angles. And then angle ABP is also 90 degrees, and that is equals angle ECB. So we have all four angles of the quadrilateral AECB is 90 degrees, so it's obviously a rectangle. So therefore in AECB we get AE equals BC or CB, and AB equals CC. All angles are 90 degree, right? So, and then the final part, now to prove that it's not only a rectangle, it's actually a square, we have to find out, we have to get into triangle congruency. And so we look at these triangles, triangle ABM and triangle AED. we see that AD equals AM. Okay, so this is AD and that equals AM. Angle AED, that is this angle, equals angle ABM, that's this angle, and that is 90 degrees, and angle EAD is 15 degrees, and angle, sorry, EAD is here, EAD is 15 degrees, and that equals angle BAM, that is also 15 degrees. So AAB equals AE equals BC equals EC. So ABCE is a square because all sides are equal. And that concludes our proof, because then AB equals BC and AB equals BC, and we have proved it.